Welcome to this Houdini notebook tutorial. This video is part of the terrain notebook. And in this video, we're looking at the HeightField Erode node. Once again, this is going to be a sub-level geometry node. So over here, I just have a height field that I've already set up. Now, this height field is fairly detailed, and I'll take you through a quick run through of this. If you're not interested, you can just skip ahead slightly. So I have a height field. And with that, I'm just adding a slight noise to distort the initial values. After that, I'm using a height field pattern with a fairly high blur. So all you're doing is increasing the blur radius and adding some distortion to it. Over here, I use a height field slump. The only thing is that I go over to the layer bindings and then change the material to slump to height. This causes these nice little sharp peaks and gives you a sort of dune-like effect. Then I have a distort by layer. And this is just distorting along a wally noise, which I'm controlling over here. So we create a noise over on the side. It's an F2 minus F1 cellular. And then over here, we distort by layer. I like to use a negative display scale because that has an inflationary effect when you're using wally. And so you don't end up with peaks that are pulling together too tightly. We then increase the substeps because if it's too low, you end up with this rough sort of look in the terrain. So just push that up until that goes away. Over here, I'm just painting in some areas where I want my peaks to be, inverting it, blurring it, and then on this height field remap, all I've done is I've reduced the max ranges of those areas, right? So now we have some areas that have peaks. Then we just use a height field distort with a fairly small size and amplitude. And over here on this height field noise, all we're doing is setting it to maximum. And if you pay attention to these flat areas over here, all it's doing is it's adding what appears to be smooth walkable ground in between our cliffs. So that's all we're doing over there. Now, why would I go through all of that effort before going into a height field erode? Well, the reason is the height field erode needs a lot of detail for the erosion to work correctly, because the height field erode has two parts to it. It has a hydro erosion element and a thermal erosion element. The hydro erosion element is going to thrive off of these sorts of curves in your landscape and things like that, and all these sorts of divots and peaks where the water would flow and cause flow lines. As for thermal erosion, any of these exposed areas, like the top of this cliff face over here, that'll sharpen up due to thermal erosion. So to get the most out of erosion, make sure that you have a decent amount of detail going into your erosion. The only other thing to pay attention to is that we're going to be doing more than one level of erosion. The first level of erosion is going to be to carve out interesting detail in our terrain. And then the second level is going to be for finer detail. So if we take a look over here, I just have this as a voxel size of 2. So that's if you leave the default height field over here to a grid spacing of 2. That's not very high resolution. And so this is going to be our low res erosion that we do first. And to do that, we're going to drop a height field erode, just the regular height field erode. And we're going to jump back to the first frame or else it'll start cooking because it is a simulation. So you will see a visualization unless, of course, you have your materials disabled over here on the side of your viewport. We can disable it if we want, but for now, I'm going to keep it up. If we go over to the main tab on our height field erode, we'll see a couple of things. So firstly, we have hydro and thermal. Now, these are going to be two different types of erosion, and as you may infer from the name, hydro is going to be anything to do with rain or water flow, anything like that. So I'm just going to drop the erodibility on thermal to 0 so that we can focus on hydro and then come back for thermal. So over under the advanced tab, you're going to find all of the controls for your hydro and thermal erosion. So you'll see over here that there is a section over here for hydro, then a section down here for thermal, then we have precipitation, water flow, debris flow. Right? So these three over here, precipitation, water flow, and debris flow, these are separated out from these two up here, but you'll generally start by working on your hydro and thermal erosion and then moving down over here to fine tune these settings. So if we go ahead and play this back with default settings, we can see what we have. Over time, we'll have some areas that carve into our terrain. We'll end up with these sort of waterways and this pooling of water in certain areas. About 25 frames is generally the sweet spot, so you can go anywhere between 20 and 30 frames. Sometimes you may need less, sometimes you may need more, but 20 to 30 is where the simulation tends to even out. So I would say around 25 frames. Right, so this is what we currently have. Now, it's all right, but we're not getting the interesting detail that I'm looking for. For example, we are kind of getting a sort of cutting in over here, and there is some detail, but not exactly what we want. So to enhance that sort of look, what we can do is make some changes to this. And this is actually recommended in the documentation. But if we go over to the erodibility adjustments over here, we have these three settings. This ramp up iterations is the idea that rain won't cause erosion when it first starts, right? So the first rainfall won't cause erosion. It's a cumulative effect. So as it rains more, we end up with more erosion. So it starts out gentle and our erosion increases over time. We don't want that for our first level of erosion. We're just using it to carve out details. So there doesn't need to be a ramp up. So we can set this to 0. The initial factor is going to be a scaling value. So it's going to scale up from 0.5 to a full erosion value, but we can set this to 1. So it starts with full erosion. Then we have this slope factor, and this defines how much erosion is controlled by the slope and angle of our terrain. So if we drop this to 0, we're saying that we can ignore the slope and just apply fairly uniform erosion throughout our terrain. And then finally, under riverbed, it is recommended that we increase our sediment capacity. This is just going to allow our channels to carry more sediment. Now, if you play this back, we should have areas in our terrain which are much more interesting. We'll have deeper cuts and they'll be more defined. So again, running it to frame 25. If we now take a look at the channels in our terrain, we're ending up with much more interesting carving going on. All right, now what do we do about these peaks? You can see that the peaks aren't really changing much. If we go to the first frame as opposed to frame 25, there's really not much going on. That is because we have disabled our thermal erosion. If we go back to our main tab and put our thermal erosion back up to 1, you'll now see a different look as well because we've re-enabled thermal erosion. This is going to carve away at the areas that are exposed to thermal conditions. So our peaks are going to sharpen up. Once again, after 25 frames, this is what we have. So we've ended up with a much more well-defined set of peaks. We've gone from this over here to this over here. Now, one thing that you may notice is that in our original terrain, we have these sort of sheer cliffs over here. And when we use our HeightField Erode, it smooths those areas out. This is where we can actually look at the cut angle under our thermal. But the thing to know about this cut angle is that the lower this angle is, the smoother it's going to cause our slopes to be. So if we push this up to something like, say, 75, which is quite a high value for this, and you oftentimes won't go that high, but if we set it to that value, you'll notice that it doesn't cut into those areas as much. It allows us to maintain these sort of sharp, jagged areas, which are flatter on the tops. So I'm going to go ahead and put this to a value of about 55, and that should be pretty good for maintaining these details that we have. All right, once you're happy with the simulation, you can find a frame where you think that the terrain looks good, and then you can freeze it at that particular frame. You can see at the top over here that we can freeze our simulation at a particular frame. So I'm going to freeze this one at frame 24. And now if we play this back, there won't be any changes, right? So this is good because we can continue on from here without this having to recook each time. And you can think of this almost as a checkpoint, right? So if we make a change up here, it will have to recache, but it won't have to recache every time we make changes below it. So that's what we now have. This is now the base state of our terrain. The only other thing that I want to show you is if we enable our visualization over here. I'm going to quickly go down and change the debris to some other color like pink, just so that we can see what debris actually is. You'll see that it's this collection at the base of our peaks, right? There's these areas where debris collects, and these areas are going to tend to be a bit rough. And if we go over to our advanced settings over here, this is defined by our debris flow at the bottom over here. Now, one thing I also want you to take note of is that the water areas are going to be smoothed out. So if I just go to an area where there's water, you'll see that this water area is smooth. That's because we've enabled post smooth on our water flow. We can do the same thing for our debris flow if we want. So generally this debris flow is going to be dependent on whether or not there's too much noise occurring and it's getting too rough. If it does get too rough, you can enable post smooth. So that will be the first level of our erosion. So from here, what we might do is run a second level of erosion. The way we would do that is by firstly resampling our HeightField. So over here, we had a grid size of 2. If we take a look over here, that is a voxel size of 2, so a grid spacing of 2. What we can do is drop this HeightField resample, drop the filter scale to a value of 1, and then change the resolution scale. So we can either increase or decrease our resolution. In this case, we're going to set it to 2. That's going to double our resolution, but you could go even higher. It's like 2.5, right? So now you'll see that we have a much smaller voxel size, which means we'll be able to get a lot more detail into our terrain. This is where we're going to use another HeightField Erode. So HeightField Erode over here. And for this one, we're not going to do those changes over under the Advanced tab, where we make adjustments to our erodibility. We want to keep this ramp up iteration initial factor and slope factor as they are. One thing that you may want to do is that before you run the simulation, we can actually clear our water and debris layer, thus treating this like just a regular terrain. So this is now our base state for our terrain. Now from here, we can once again run a simulation. And this one over here is going to carve in much finer details. It's also going to take longer because we have a higher resolution for this to run over. If we take a look at the difference between our first HeightField erode and our second, you'll see that we have a lot of this finer detail. Now, of course, once again, you will be wanting to make all sorts of changes to this secondary erode. For example, if we want to still maintain these shapes over here, we can once again increase our cut angle up to something like 45. We can go over to our advanced tab. And over here, under precipitation, this is going to control the types of channels that we have and also the type of rain that we have. For example, if you want an area that's going to be more dry and arid, then you may want to increase the evaporation rate or simply decrease the precipitation. You're going to end up with less of these channels that cut into the terrain. And as you decrease your evaporation rate, you're going to end up with more pooling to create things like lakes or rivers or whatever it may be. As for raindrop settings, this is going to smooth out our areas of water. So we're going to end up with smoother channels and smoother lakes. If you ever want to see what sort of changes we should be making to get certain looks, we can also go over here with the HeightField erode node selected and click on this question mark. This will bring up the documentation. And the first few things at the top of the documentation are probably the most useful. So the first thing that you'll see is this over here, controlling the look. So you can see that if we want to change channel shape, we can do these things over here. If you want to change ridge shape, change these over here. If you want to change your lakes, you have these settings here. And debris, you have this over here. You'll see that it also has these tips and notes about what I've mentioned in this tutorial. For example, for first pass erosion, so the one that you're doing on your low resolution HeightField, you're going to want to set your ramp up iterations to 0, initial factor to 1, and slope factor to 0, as well as increasing the sediment capacity. You can see that we also did switch our debris post smoothing on. And then the only thing that we didn't really look at is this grid bias. So grid bias is just how much should our erosion follow the contours of our terrain, and how much should they follow the principal axes, so X, Y, and Z. If we want a varied erosion throughout our terrain, what we can do is we can affect that grid bias by applying a mask to it. You can see that the mask is called Hydro Grid Bias Mask. And so all we have to do is use a mask by feature. So HeightField mask by feature, like this. Let's use slope and direction. Something like that, increasing the spread angle. That should be good. And then over here, all we have to do is a copy layer. So HeightField copy layer. And with this copy layer, we just need to give it the same name as what it's expecting. So Hydro Grid Bias Mask. Hydro Grid Bias Mask. Then we plug that into the HeightField erode, and this is going to cause some variation on those masked slopes. Now, it is recommended to remap this range because it is currently between a range of 0 to 1. So we can use a remap. So HeightField remap right over here. We're not going to remap our height. We're going to remap our Hydro Grid Bias Mask. Over here, we can compute the range and then set the output minimum to -1. Then if we put that into our HeightField erode and then run it, then this is going to work as recommended in the documentation. We're going to have a variation in our erosion depending on which areas are masked. And you can also make changes after the erosions occurred. You can use things like HeightField noises to reintroduce tiny amounts of detail. So if we just set this to some small value like 10 and 10, reducing the amplitude, and then once again using a HeightField distort, we can add that tiny bit of variation that makes this just that much more believable. So that's how we go about using the HeightField erode nodes, and I hope that this helped you. So just to recap, generally what we would do is try to add as much detail to our terrain as possible before putting it into our erosion, run our erosion to cut out some of these more basic details by going over to the advanced tab, erodibility adjustments, doing 0, 1, and 0, and increasing the sediment capacity under our riverbed, then going down here and smoothing out the debris flow. We then resample, so we're going to increase the resolution of our HeightField, run it through a second HeightField erode, and this one is going to be for finer detail, optionally adding a Hydro Grid Bias Mask over here, then running this through a HeightField noise and a HeightField distort, just to reintroduce some of those very small imperfections. So that's all for this video. I'll be seeing you very soon with another video. Thank you for watching. Bye.